Hello and welcome to this session on real-world percentage problems with me, Mr. McIver, here at the London Central and North West Maths Hub. To make sense of this video, you should be familiar with the content of Percentages with Multipliers 1, the first video I did on this topic, which runs through the following key ideas. To work out a percentage of a number, such as 80% of 50, you convert it into a simple multiplication sum, 80 hundredths times 50, which is simply 0.8 times 50. To work out a percentage change, you carry out a very similar procedure. For instance, to increase £50 by 17%, you reframe it as a percentage of question, where the percentage is simply a number above 100%. And of course, 117% is simply 117 hundredths times £50 or 1.17 times £50. In the same way, to reduce by percentage, you just have to ask yourself, what percentage of the original amount will I be left with? In this case, it's 100% minus the 25% reduction, or 75% of the original quantity, 0.75 times. And the final technique addressed in this first video was repeated percentage change, which very often emerges under the heading compound interest or occasionally depreciation. A typical question would be this: increase £1,500 by 12% for 3 years. Well, that simply means work out 112% of £1,500, then 112% of that amount that you got as the answer to the first part, and then 112% of that amount, which in fractions can be written as that, 112 hundredths times 112 hundredths, etc. Or, in shorter form, 1.12 cubed times £1,500. The second video looked at one number as a percentage of another. For instance, convert 56 out of 80 into a percentage. If I think of x percent of 80 as 56, I can rewrite that as x hundredths times 80 equals 56. I rearrange the equation and end up with that. X is simply 56 over 80 times 100, 70. So 56 out of 80 is 70%. In a very similar way, I can find a change as a percentage. A price is reduced in a shop from £45 to £36. First thing I do is work out the actual reduction. I then have to work out £9 as a percentage of £45. Using a similar calculation to the one before, x hundredths times 45 is 9. I rearrange and get x is 9 over 45 times 100, 20. So it's 20%. And finally, finding an original amount after a percentage change. For example, after a 15% increase, the price is £46. The best way to understand this is simply to think the increase is 15%, so the figure I've got is 115% of the original price. Notice I don't know what the original price is, so it's no good working out 15% of anything. What I have to do is notice that 115 hundredths times my original price is 46. I then just do a little bit of rearranging using algebra and come to the conclusion that P equals 40 in this case, so the original price of my item is £40. That was a very quick recap of all the percentages we covered earlier in this course. If you have any difficulty with any of them, look back at those earlier videos. And the first real-life application we're going to look at is claiming back value-added tax, claiming back VAT on purchases that have been made in the United Kingdom. This is a calculation that's done every day in the UK by bookkeepers the length and breadth of the country, but we're going to look at a simple example of an American tourist flying back from Heathrow to Chicago, taking with them this delightful antique table purchased from an emporium in the Midlands of England. This table cost the tourist £780, including 20% value-added tax. But of course, VAT is a European tax. The American tourist doesn't need to pay it because they're not buying this object for the UK. They are exporting it. So what they have to do is figure out how much money they can claim back from the Exchequer before they get on their plane. And they do this by filling in this rather attractive looking form. It's got all the usual details on it: name, passport number, arrival, departure time, and most importantly, on one of the inner pages, the figure for the amount of cash the tourist wishes to claim back from the inland revenue. Well, that £780 is of course 120% of the VAT-free price. Or if you like, 1.2x equals £780, where x is the original price before VAT was added. Now, we could follow through the calculation shown earlier and just divide both sides of that equation by 1.2 and work out what x is, but the bit you need to enter into the form is the VAT bit, and that's just the 0.2 part of this calculation. So what I can do is I can divide both sides of this equation by 6, and on the left side I'm just left with 0.2x, which is the VAT bill. And in this case it's £130. So on one of the inner pages of this form, our American tourist has to fill in the figure of £130, which will be immediately credited back to his credit card by the Inland Revenue. Now let's look at a slightly more complicated situation. Let's look at how you price an item for profit. Here is a traditional British toy, available at good souvenir shops everywhere. And this particular toy has certain costs associated with it for the manufacturer. I've broken these in two. The raw materials, the paint, the metal, the wheels, the plastic, are 40% of the cost, and the manufacturing and distribution costs, which account for the other 60%. 100% in all. And of course, on top of these costs, the manufacturer wants to make a profit, in this case of 25%. Now, I'm not going to tell you what that bus costs. What I am going to tell you is that the cost of production is going up. The raw materials are going up in price by 20%, and the manufacturing and distribution costs are going to increase by 10%. If you are the manufacturer of this toy bus, the question you need to ask is, what is going to happen to your profits? To work this out, it's much easier to assign actual costs to things. And we are going to invent a production cost for our toy bus, and we're going to make it £100 because it makes the sums easier, not because I think this bus is actually going to cost you £100 to make. Now, if this bus was to cost £100, then under the old regime, the materials would cost £40, the manufacturing cost would be £60, and the profit would be £25, leading to a price of £125, of which you sold it to the shops and souvenir outlets around the country. But the situation has now changed. So under the new regime, the materials have gone up in price by 20%. So they are now costing you £48. The manufacturing costs have gone up by 10%, taking them up to £66. And the profit and selling figures, well, we'll come back to those in a moment. Let's look at what's happened to the manufacturing cost. It's now up to £114. Now, I suppose what we could do is we could say the selling price is going to stay the same. So our profit is the difference between £125 and £114, which is just £11. Our profit is significantly less than it was, 9.6%. But of course, as the manufacturer, you've got a choice about what you do. You don't have to go on selling this thing at the same price as before. What you could do would be to pass on the entire increased cost you have for your manufacturing onto the consumer. So, in this case, our manufacturing cost is still £114, but to find out what we sell it for, we are simply going to add 25% to that manufacturing cost and arrive at a total of £142.50, turning a profit of £28.50. But look what's happened to our selling price. It's gone up from £125 to £142.50, an increase of 14%. Notice we could have seen that right here. Our manufacturing costs have gone up by 14%, so if we pass it on to the consumer, we'll be selling it for 14% more. So, in answer to the question, what happens to your profit, you as the manufacturer have a choice. Option 1, hold your prices steady, try to maintain or increase sales, and simply take the hit on profits, down from 25% to 9.6%. Option 2 is to increase the prices. Keep your margin at 25%, but risk a drop in sales as your buyers look for a cheaper supplier. Or you can choose some combination of the two. Put up prices a bit and try to increase sales a bit. But these are the figures that allow you to make a rational and informed choice. Now let's look at a more complicated situation, double glazing. And the thing about double glazing is no one expects to pay the list price. Everyone wants a discount, but you still have to make a profit. Let's suppose you want to make a profit of 20% after paying your VAT and after your salespeople have offered a discount of up to 60%. What are the headline prices you put in your catalogue for these items? As before, let's invent a production cost for the product. In the case of the toy bus, £100 was obviously too high. In the case of double glazing for a house, it's clearly too low. Doesn't matter, it makes the sum simple. So, £100 to double glaze a house, and you want to make £20 profit. So that means we want to sell it for £120, but we've got to take into account VAT at 20%, so we have to be charging our consumer £144 for that £100 worth of double glazing. Now, I want to be able to give a discount of up to 60%. In other words, I need to make sure that my minimum price is covered by 40% of the list price. Well, now it's quite a straightforward reverse percentage calculation. 0.4x has to equal 144. So that means x, my list price, is 144 over 0.4, £360. Now, don't worry about the actual prices here. The point is, that represents 360% of my costs, or a markup of 260% in the catalogue. Before we finish, I just want to talk about one more quirky thing you can do with percentages, figuring out an average percentage change. And to explain this one, I'm going to look at RPI, the Retail Price Index. It was covered in an earlier session. Do go back and look if you can't remember how it works. It's just a way of tracking prices over time. And here I have a list of RPI figures going all the way back to 1970. If you're interested, the baseline year was 1974 in the month of January. And the question I want to ask is this: by what percentage did prices increase between 1990 and 1995? Well, that's pretty straightforward. You just look at the indices for 1990 and 1995 and you get a multiplier for that 5-year period. Well, a multiplier of 1.182 corresponds to a percentage increase. Prices went up by 18.2% in that 5-year period. But what was the average rate of inflation over this time? Do you just divide 18.2% by 5 because it's 5 years? No. If you think of the 1-year multiplier as x, we've applied that 5 times, once for each year. So in fact, x to the power 5 has to be our 5-year multiplier. And to get our 1-year multiplier, we need to take a 5th root. Our 1-year multiplier is therefore 1.034, corresponding to an annual inflation rate of 3.4%. And this business of taking roots is how you figure out average percentage increases over time. But to recap, the big idea in today's session was whenever you've got a complicated looking percentage problem, work with actual amounts and switch back to percentages at the end. Wherever possible, use a baseline figure of 100. 100 makes the percentages much easier to spot. The second thing we looked at was average percentage change. And when you're dealing with compound interest over time, this always involves the use of roots, because compound interest is powers, so when you go backwards, you have to use roots. That's it for this session. Now, work through the questions that you have been set.